Doing all right? So after your quizzes, if you had different scores than what you were expecting, there was probably some rounding error, or you didn't just type in the answers as I had put them in for the answers. I went back through, regraded. Okay, so go recheck your answer or your grades if you haven't done so already. I know Zoe was already talking you about rechecking it. So go back and check. And one of the things you just want to make sure, yeah, that's right. But one of the things you want to make sure that you don't round until the very end. That's what can cause some discrepancies between what I had and what you might have had for answers. I think I have an old test too here, Gavin. I have an old test here too. All right. So that's the big thing. But if your answer was close, clearly you were doing what you were supposed to be doing. So that was why I went ahead and gave Phil credit. Okay. Main reason why I wanted you to do that was just mainly to remind you about exponential models, since it's been a while since we talked about them. And the stuff we've been talking about since then is different than what that exponential model stuff. But we're having our test, in a couple of weeks. So I want to make sure that you kind of went back and reviewed it a little bit before you go back and start studying for the test. So that was the main reason for quiz stuff. All right. What questions do you have before we get started? We're going to finish up section 9.3 today, which is about doing matrices and using matrices to help us solve systems of equations. All right, so last time we talked about how we can write our systems of equations as augmented matrices. So remember when we did that, let me go back up. When we did that, let's look at this example here. When we did that, remember that in our first column, these were all the coefficients for the x's. In the second column, these were all the coefficients for the y's. In the third column, these were all the coefficients for the z's. The vertical bar represented our equals, right? And on the right side, we had the constants. Before we can do this, of course, we need to make sure we have this all nice and lined up this way, right? So if your system of equations is written slightly differently, you may have to reorganize, which is what we did in that example, right? We reorganized a little bit and then wrote our matrix, right? Okay. And then we talked about this idea of being called reduced row echelon form. And this is going to be our goal today, to be able to write these matrices in reduced row echelon form. So first, we need to make sure that if there are any rows of zeros, all the rows of zeros are at the bottom of the matrix. If we have something that has non-zero entries, as we read from left to right, the first non-zero thing that we have has to be a 1. Okay? Any row that you go across, the first non-zero thing has to be a 1. And we refer to those as leading ones, or we call them pivots. Those are the answers that are, those are the words we give to those particular ones. The third one was that as you go down the rows, those leading ones have to move to the right. So we have to have that stair-stepping idea. Remember, we talked in the previous section about writing our systems in triangular form. Okay? This is the analog to that for matrices, trying to do that triangular form. Also, remember when we put things in triangular form, we got ones and then got zeros below, right? For reduced row echelon form, we don't only want zeros below those leading ones, but we also want zeros above the leading ones. Okay. So looking at this first example, we talked about this briefly at the end of class last time. This first example here, this is in reduced row echelon form because here's a leading 1. We have zeros below it, right? Here's a leading 1. I have zeros above and below it, and that leading 1 is to the right, right? Going down to the next row, my leading one is off to the right again. I have zeros above it, and then I've run out of rows. Right? Now, why do we like this form? Well, again, if we correspond this to a system of equations, what does the first row tell you? X equals 4. It tells us the answer to x, right? What does the second row tell you? Y equals -1 or -3. And the last one, z equals 1, right? It tells us the answers. All right, so that's why we like reduced row echelon form. And again, the method that we're going to do today talks about putting these matrices into reduced row echelon form. What about the next matrix? Are all the rows of zeros at the bottom? Yes. Is the going across your rows is your first non-zero entry a 1? Yeah. Looking at that leading 1, does it have zeros above and below it? Yep. So is this in reduced row echelon form? Yeah, it is, okay? So this one is in reduced row echelon form. Oops. Okay, so it is in reduced row echelon form. Let's look at the second row. What equation does the second row correspond to?
X minus 2y.
The second row.
Oh, sorry. There must be 0.
Yeah, 0 equals 0, right? The second row here says we would have 0x plus 0y, which is the 0, right, equals 0. Is that a true statement or a false statement? That one's true, right? So again, here we notice that the second row says 0 equals 0, which is true. When we saw that in the previous section, what did that tell you about the number of solutions of the system? Infinitely many, right? We agree? Okay. So this tells us, and that's exactly what this is going to tell us, is we have infinitely many solutions. Now let's figure out how to write them. Okay. Now let's go back to that first equation. Elliot, what would you have for that first equation? That first row, tell us.
X minus 2y.
Good. X minus 2y equals 3. Right? And this is when we had to write that in that parametric form. Notice that our y can be anything. But if we solve for our x, we'll get 2y plus 3, right? And so we can write our solutions xy will be 2y plus 3 and then comma a y. Remember that when we have infinitely many solutions, one of our variables we treat like it's a parameter. Well, that just means that it can be any number that you want. Okay? So if I pick a y, though, I know exactly what my x has to be. Okay. So when I write it as an ordered pair, y can be anything, but then my x has to be 2y plus 3 from that equation. Okay? I know it's a little weird, I know. Okay. All right. Let's look at the last one. Is that in reduced row echelon form? Well, we don't have any rows of zeros, right? Look at that third row. Is the first non-zero entry a 1? No, it's not. So this is not in reduced row echelon form, okay? Oops. However, it's pretty close, isn't it? That 2 would need to be a what if I was going to put it in reduced row echelon form? What should it be instead? A 1, right? It had to be a 1, wouldn't it? If it's going to be in reduced row echelon form? Okay. Now, if I ignore the last column, if we pretend like that last column is not here for the time being, is that in reduced row echelon form? If I ignore, just pretend like the last column is not there, are all the rows of zeros at the bottom? Yep. First entry of 1 in each of the other rows? Yep. Is a stair step to the right? Yep. Are there zeros above and below the leading ones? Yeah. So if I just look at this part, that is in reduced row echelon form. That just does that first 3 by 3 part. Okay. All right. In any event, the whole goal of this is to be able to try to read off the solutions. What does the last row tell you?
No,
No, because why?
because it's a false statement.
It's a false statement. Yep. So it says, this one says that 0 equals 2, doesn't it? Right? That's 0 on the left side, 2 on the right. So you get a false statement. So this last row, the third row, says 0 equals 2, which is false. If I could spell the word false, that'd be helpful. So that tells us that we have no solution in this case. Okay. All right, so the whole point of this, from our perspective, is to try to rewrite these augmented matrices in reduced row echelon form, or at least where our part to the left-hand side of the vertical bar is in reduced row echelon form, to help us read off the solutions. That's our goal. Okay? All right, so to do that, we're going to have a method to help us with that. But to do that, we need to talk about the operations that we're allowed to do to do the algorithm that we're going to use. All right? So what the operations that we're going to use are referred to as elementary row operations. And these are going to correspond to those exact same operations that we already talked about in the previous section that we used to put our system of equations into triangular form. So we had 3 operations that we could do. The first one's going to be swap 2 rows. This corresponds to the operation that we had before of swapping 2 equations, right? We already talked about that in the previous section. Remember now, what we're going to do is we're going to convert our systems into augmented matrices. And instead of having to write the x's and the y's and the z's every time, we're just going to keep track of the coefficients. That's what the whole goal of this is. Okay? So swapping 2 rows corresponds to swapping 2 equations. Okay? We can multiply a row by a non-zero constant. This was multiplying an equation by a non-zero constant. That was the corresponding thing that we did in the previous section. The third one was the weird one, right? Where you multiply by a constant, add it to another equation, and replace that other equation. Do the same thing here. We're going to multiply one equation or one row by a constant, add to a second row, and replace the second row. That's corresponding to the same thing we did with equations. Let's multiply one equation by a constant, add to a second equation, and replace the second equation. Okay, just like what we talked about for equations, This third type of row operation does not change the original, that first row that you multiply the constant by. Only one row is getting changed. Okay. The only reason why I put these in parentheses on the side is because we've already talked about doing these things for equations, right? It's literally the same thing. Okay? All we're doing with the augmented matrices is just a record-keeping thing for us, right? The x, the y, and the z never changed as you went along. All we changed were the coefficients, correct? So all we're gonna do is just keep track of the coefficients and then know how they correspond. Okay. So the method that we're gonna do is referred to as the Gauss-Jordan method. What are you doing that for? All right, so it's going to be very repetitive, but the repetitions that we're going to do correspond exactly to what we talked about in the previous section. Okay, so remember, what was the first thing that we did when we wanted to put a system in triangular form? What was the first step? What was the coefficient on the x? Well, 1, right. So we wanted to get a 1x in the upper left-hand corner. That's going to be the exact same thing, right? It's going to be the exact same thing for this process. We're going to get a 1 in the top left corner of the matrix. Excuse me for just a second. I want to see what's going on in the hallway.
Wait, do they have to with the budget? Yeah. I should. Yeah, I got some extra credit points too. Dang. Yeah.
Sure, come on in. That's fine. There's no audio, so you're good. Okay, great. All right, cool. All right, so again, first step is to get a 1 in the upper left-hand corner here, right? Okay. What was the next step that we did after we got that 1 in the 1x in the upper left-hand corner? What was the next step that we did? This is the previous section stuff, right? After we got a 1x in the upper left-hand corner, what do we do after that? You got the rest of that thing is in that column 0, right? So the first thing after we get that 1 in the upper left-hand corner, we're going to get zeros below that 1. Okay? That's going to be the next step. Okay, and then we're going to start repeating this process. Okay, what did we do next? After we did the first 1x in the upper left-hand corner and got zeros, what did we get next? A 1y, right? So now get a 1 in the second row. I should say a leading 1. Let me change that. Get a leading 1 in the second row. What did we do after that? Got zeros below it. Now this is where the one difference is going to come in. Since we're going to put it in reduced row echelon form, we don't only want zeros below it, we also want zeros above. Okay? So the next step will be get zeros above and below that leading 1. and then repeat until you run out of rows. Okay. We're just going to keep doing this over and over again until we run out of rows. Good news is that at most you'll ever have is 3 rows. Okay. You could have, yep, you're welcome. You could have bigger systems of equations. You might have more equations and more variables. We won't go anything more than with 3 equations and 3 unknowns. Okay. I know that was a little weird, wasn't it? Yeah. It was even creepier when he was just standing outside outside the room. It was just recording. So it was. Well, was what I wanted to check. It was literally our marketing department, so it was all right. So don't worry about some just random person just videotaping all of it. Surveillance for the attack next week. Something along those lines. All right. Anyway, so this is the process. The process is going to be the same every time. Get a 1, get zeros. Get a 1, get zeros. Get a 1, get zeros. It's always going to alternate like that. Get the 1, get the zeros. Get the 1, get the zeros, and so on. Okay? So let's see if we can do an example. All right. So this system has already been put as an augmented matrix. What would be the first equation that first row corresponds to? What would the equation with the first row correspond to? Good. So yeah, that would correspond to 2x plus 5y plus z equals negative 4. The next one would be what?
X plus 7z equals negative 2.
Yep, x plus 7z equals negative 2. The third one would be negative 3y minus 2z plus equals 11. Right? Good. All right, so the first step, again, is to get a 1 in the upper left-hand corner. There are 2 ways that we can do that. Either I could divide the first row by 2. That would work, right? But that is going to put some fractions in there, and I'd like to avoid the fractions if I can. Do you see another way where I could get a 1 in the upper left-hand corner without having to divide anything? Yeah, just swap with the second row, right? So using the similar notation that I did with the equations, rather than using an E, I'll use an R for row rather than equation. I'll write R1 and then R2 with a double arrow like that. Okay. So we'll take the second row and put it in the first row spot, and take the first row and put it in the second row spot. Okay? That part okay? That's always step 1. Get a 1 in the upper left-hand corner. Okay? The next step is to get zeros below where that 1 is. So I want to make this 2 right here into a 0. We're always, always, always going to work off the leading 1 to do that. Okay? What do I need to add to the 2 to make it go away? Make it into a 0. Negative 2, right? Just need to add its opposite, right? So we're going to take negative 2 times row 1 plus row 2 and replace row 2. Remember again, the only row getting changed with this operation is row 2, right? Even though it says do negative 2 times row 1, that's an intermediate step, right? It's a helping step, okay? So we don't actually change row 1 at all, okay? Okay? Do negative 2, and now we're just going to do it term by term here, or entry by entry. Negative 2 times 1 is negative 2, plus 2 gives you a 0. Negative 2 times 0 is 0, plus 5 gives you a 5. Negative 2 times 7 gives you negative 14, plus 1. Oops, no, that's right. Negative 2 times 17 gives you a negative 14, plus 1 is a negative 13. right? Negative 2 times negative 2 is 4. Minus 4 gives you 0. And again, we didn't change the third row here. Yeah.
Is there a reason we didn't switch it with the third row? Since it has the 0.
Didn't switch which one with the third?
2 and 3. Row 2 and 3.
Oh, because I have to get zeros all the way down.
Okay.
So it didn't matter.
All right, gotcha.
I could have swapped it, but then I still would have to get rid of the 2 anyway. Yep. This okay? All right. We got a 1. We got zeros. What's the next step? Remember, it alternates. Get a 1, get zeros, get a 1, right? I want to make this one a 1. Okay? I can't do a swap here, unfortunately, because I don't have a 1 in the other spot anyway. So I'm going to have to bite the bullet and work with fractions. I know. It's not fun. I'll do 1/5 row 2 and replace row 2. Divide everything by 5. We'll get a 1 there, a negative 13 over 5 there, and a 0 there. And we still don't change the third row. That part okay? All right, so again, got a 1, got zeros, got a 1. Next step is get zeros, right? So I need to make this negative 3 go away. What do I need to add to negative 3 to make it go away? 3. So we'll take 3 times row 2 added to row 3, replace row 3. Row 1's not even involved. Row 3 is the one we're replacing, so we don't actually change row 2, right? The only row that's getting replaced at this point is row 3. Okay? Now, this is also very important, by the way. When you're getting the zeros, always work on the leading one you just got. Don't try to use a previous leading one because it's going to mess you up. Okay? Always go from left to right. Don't try to go back left again in a later step. Okay? Always going to go left, right and down. Don't ever go left and up. Okay? All right. 3 times the 1 is 3 plus the negative 3 gives you a 0. So I have 0, 0. Now I got fractions. 3 times negative 13 over 5 is negative 39 over 5 minus 10 over 5. That's what negative 2 would be. So I'd have a negative 49 over 5. That's what calculators are for, right? But the last one's pretty easy. I don't know why I made the numbers so nasty here on this first example. What do you get for the last entry here? It says 3 times row 2 plus row 3. 3 times 0 is 0 plus 11 is 11. Yeah, didn't change that number. So far, so good with the process, even though the numbers are a little bit ugly. I got to remember to change this example next time I teach this class. It's not a good first example. All right. We got a 1, we got zeros. We got a 1, we got zeros. Next step, get a 1. I need to multiply this by its reciprocal, right? So I need to take negative 5 over 49, row 3, and replace row 3. Doesn't change the first 2 rows. Zero, 0, 1. Ugh. 5 over 49. So I get negative 55 over 49. We're almost done. Got a 1, got zeros, got a 1, got zeros, got a 1. get zeros, right? So I need to make both of these entries now 0. Okay? Let's work on the 7 first. What do I need to add to 7? -7. So what operation do you think we're going to do to make that a 0? I need to add a -7 right there. What do I need to do? Always work off your leading 1. What do we want to do? Yeah, we'll use the bottom row. Good. So what do I want to multiply the bottom row by? -7 and add up, right? Right? Okay. That doesn't change your bottom row. The top row now becomes 1, 0. It better be a 0. We rigged it that way, right? -7 times 1 plus 7, right? Oh, the last one here. Well, -7 times -55 over 49 will give me a positive 55 over 7 minus 14 over 7. 55 minus 14 is 41, so I should get a 41 over 7 here. Right? Use calculators. If you need help with figuring out the fractions, I can help you with the fractions on the calculator too. Okay? Or Hope can help you out with that too. Okay? All right. I got a 0 here. Now notice I didn't bother writing the second row in here because what else do we need to be a 0 to finish this off? The -13 over 5, right? So I'll need to work off of this again. So what do I need to multiply row 3 by to make that go away? What do I need to multiply row 3 by? 13 over 5. Good. 13 over 5, row 3 plus row 2, replace row 2. I might as well just do them both at the same time, right? If you want to write them in separate steps, that's okay, but I might as well just go ahead and do it all at the same time. Okay. Notice that gives me 0, 1, 0, right? Oh, goodness, that's ugly. 13 over 5 times 55 over 49. Well, that's -13 times 11, which is -143 over 49. So I'll get a -143 over 49 on this spot. Like I said, that's what the calculators are for. The important part is here is understanding the approach. Now we're done. Now again, if we were, this problem was set up as a matrix to start with, but if we were solving a system, can you read the answers now? What's the x value going to be? 41 over 7. What's the y? -143 over 49. The last one's going to be -55 over 49. That's the reason for this process, right? We're able to read the answers easily. All right. So let's see if we can put this to use to solving systems of equations. So let's hope these are a little bit nicer than those fractions. Maybe I did a better job of picking examples than I just did on that one. All right. So it says, write the augmented matrix and then use Gauss-Jordan. Okay. So first, what does your augmented matrix look like here? What's your first row going to be? Yeah, 1, 1, bar 2, right? What's your second row going to look like? Good. 1, -2, and 0. Good. Everybody okay with getting the augmented matrix set up? That's okay? All right. First step in the Gauss-Jordan method is what? Get a 1 in the upper left-hand corner. Right? That's first step. Do I need to do anything? No. There's already a 1 in the upper left-hand corner. We're good. What's the second step? Get zeros, right? Remember, it's alternating, right? You get a 1, get zeros, get a 1, get zeros, get a 1, get zeros, right? Got a 1, so the next step is to get zeros. So I need to make that go away, what I just circled in red. What operation do you need to do to make that go away? -1 times which row? Row 1. Add it to row 2. Replace row 2. Right? Remember, to get your zeros, always work on the leading one off of the leading one you just found, right? Okay. Does that change the first row? No. What does your second row become? First entry is definitely what? 0. Good. What's the next entry? -3. Good, because it's -1 times 1 is -1 plus -2. What's your constant going to be? -2. Good. Is that okay? All right. Got a 1, got zeros. What's the next step? Get a 1. Looking at that second row, what do you need to do to get a 1? Divide by a -3, right? Multiply by a -1/3. More often than not, to get a 1, you're gonna end up dividing by whatever coefficient you have there. Okay. That doesn't change the first row. What does your second row become when you divide by -3? 2/3. Good. Now the last step, I get a 0 here, right? Next step is to get a 0 here. What operation is going to give you a 0 there? And again, remember, always work off the leading one you just found. What row operation is going to work for that one? Yep, your negative row 1 times row 2, add it to row 1, replace row 1, right? That doesn't change row 2. The first 2 entries in row 1 should be pretty easy. What are your first 2 entries in row 1 going to be? Well, yeah, 1 and a 0, right? Because we're getting rid of that, right? We're making it a 0. What is your entry in the upper left-hand corner going to be? Well, I'm doing -1 times 2/3 gives me -2/3 plus a 2. 2 is the same thing as 6/3, so I get 4/3 in that one. Are we done? Yeah, we're done at this point, right? So how will we write our solution? What's your x value? 4/3. What's your y value? 2/3. What questions do you have on that one? This one okay? Do another one. Let's do the next one here. First thing we're going to do is write our augmented matrix. What's your first row? Good. 4, -6, 12. Your second row? Good. Are we good with writing the augmented matrix? If you can't do that part, it's really hard to do the next part, right? Are we good with that part? Seems like we got that. Yeah, no, maybe. Yeah. Okay. All right. Step number 1 is to get what? 1 in the upper left-hand corner. What's the easy way to do that in this case? Swap. Good. Let's swap row 1 and row 2. What else could you have done? Yeah, you could both divide by 4, right? Multiply by 1/4. That would make fractions, and I really don't want to do that. We've had enough fun with fractions today, I think. You can. Don't get me wrong. I just think it's a little bit easier to do it this way. All right, we got our 1 now in the upper left-hand corner. What's the next step? 0 in the below it, right? What operation do we need to do to get a 0 below it? Which one? Which row?
The top row.
Top row, good. Multiply row 1 by -4, add it to row 2, replace row 2. Does that change row 1? No, good. What does your second row become? You can definitely get a 0, right? That's the whole reason why we're doing that is to make that a 0, right? That gets a little bit easier. What's the next one going to be? You can just tell me what you need to do, and I'll do the arithmetic if you want.
-4 times -7.
Okay, -4 times -7 gives you 28, and then minus a 6, right? -4 times -7 gives me positive 28, plus -6 gives me 22. -4 times 14 is -56, plus 12 gives me -44 when I'm done. Everybody see where those numbers are coming from? All right, so we got a 1, got a 0. What's the next step? Get a 1. What do I need to do to make that 22 into a 1? Divide by 22. So dividing by 22 is the same thing as multiplying by 1 over 22. Well, we'll write in the notation here. Doesn't change the first row. We get 0, 1, -2. This one I made a little bit nicer, so I get fractions out the wazoo. Got a 1, got a 0, got a 1. Next step is get a 0. What do we need to do to get that last step here to get a 0? Multiply row 2 by, I think it's positive 7, right? Yeah, and then add up. That does not change row 2. Without doing any work at all, what's the first 2 entries in row 1 going to be? 1, 0, right? It's the whole point, isn't it? Right? And then 7 times -2 is -14, plus 14 gives you 0. So what's your solution in this case? 0, -2. Good. What questions do you have on that? This okay? All right. Let's do the next one here, since we're having so much fun. First step, write that augmented matrix. First row. Good. And the second row. Good. There's our augmented matrix. 5, -15, 10, -2, 6, -4. First step is to get a 1 up in the upper left-hand corner. What operation can you do here to get a 1? What do you need to do? Yeah, basically divide by 5, right? There's not any row swap that we can do. Good news is that I did pick some decent numbers here. When you divide row 1 by 5, multiply row 1 by a fifth, what do you get? Good, 1, -3, 2, and then the second row stays the same. Everybody okay with step 1? Okay. Next step is to get 0 where the -2 is, right? What operation do you need to use to get a 0 there? Multiply row 1 by 2 and add down. Good. Does that change row 1? No. Row 1 stays the same. What do you get in row 2 now? We get a 0 there, right? That's the whole point, to make that a 0. What's the next entry going to be? Also a 0, right? 2 times negative 3 is negative 6, plus 6 gives you 0. What's the last entry? Also 0. 2 times 2 is 4, plus negative 4 gives you 0. We're now done with the process, right? I can't do anything else. What does the last row tell you? Yeah, it's infinitely many solutions, right? It says 0 equals 0, correct? So to do our infinitely many solutions again, let's take that first row. What equation does your first row correspond to? Good. X minus 3y equals 2. Let's solve that for x. Let's just add the 3y. We get x equals 3y plus 2. That tells me that my y can be anything. What does the x have to be? 3y plus 2. Good. When we have infinitely many solutions again, remember that tells us one of the variables can be anything, right? We solved for x in terms of y, so we'll let y be anything, and then the x has to be the 3y plus 2 at that point. This okay? Let's do the next one, and then we'll do more of these on Monday. We got 4 minutes. We can do the next one. Augmented matrix is what? 4, 2, negative 5, and then 6, 3, 0. First step is to get a 1. Now we're going to get a 1 here. Divide by the 4. When you divide row 1 by 4, what do you get? Good. And we'll get a 1, a 2 over 4, which is the same thing as 1/2, and then a negative 5 over 4. Second row did not change. What's our next step? Get a 0 below it, right? What row operation do we need to do to get a 0 below? Okay, good. Row 1 times negative 6, added to row 2, replace row 2. I know I'm emphasizing this a lot, but does that change row 1? No. What do you get in row 2? 0 for certain there, right? What's the next entry? Also a 0, right? Because we'll have negative 6 times 1/2 is negative 3, plus 3 gives you 0. The last one, negative 6 times negative 5/4 will give you positive 30 over 4, which is the same thing as 15 over 2. Add down, we'll get 15 over 2. At this point, again, we're done, because what does the last row now tell you? Yeah, this last row says 0 equals 15 over 2, which is false, isn't it? Right? So at this point, we get no solution. We don't have to do any more work. Okay. Is this process okay so far? All right. We'll do more of examples of this next time. We'll do some 3 equations and 3 unknowns. And then we'll also get into doing some algebra with matrices. So that's Monday. Remember, no class Friday. Friday is your celebration of scholarship, so you should go support your classmates who are presenting. Have a good one. I'll see you on Monday.